We are in Unit 5, Lesson 9, and we're looking at comparing graphs. Here's the warm-up, and my idea for this is that you would do the warm-up, pause the video, do the warm-up, and then come back and check your work. So you should be open up to page 95 here, do the warm-up, pause the video, do the warm-up, and then come back and check your work. All right, hopefully you have paused the video and now you're coming back to check your work. Estimate B of 1930. So I'm going to look at 1930 here, and I'm going to go to B. B of T is the one that has the solid line here. And so that's this guy right here. And 1930 is right here. And the solid line, that's right there. That looks pretty much 800,000 is what that looks like to me. This graph shows the population of Baltimore and Cleveland in the 20th century. B of T is the population of Baltimore in year T. C of T is the population of Cleveland in year T. So explain what this means then is that in the year 1930, population of Baltimore is 800,000 people. All right, so some answer around along those lines. For number 2, here are pairs of statements about the two populations. In each pair, which statement is true? Explain, or be prepared to explain how you know. Okay, so B of 2000, Baltimore of 2000 is right here. That is, I don't know, 620 maybe? 620K. And C is down here, which is, 2000. About maybe 450K. So 620 is greater than 450, so this one is true. Okay, this is just saying that at the same points, saying now Baltimore is less than Cleveland. And we don't even have to really write these numbers out. We can just see at 2000, Baltimore, that's the solid one, remember, is greater than Cleveland. It's above Cleveland, so we know that this one is greater than even without writing in those values. Let's do that same thing with this one. In 1900, it says B and C are equal. 1900 is right here. Notice they are not equal. So this is definitely not true. And then this one, 1900 is greater than, B of 1900 is greater than C of 1900. So remember, B is the solid one. That one is greater. It's higher on the y-axis. So this one is true. There we go. Were the two cities' populations ever the same? If so, when? So we've actually have two places where that happens. One is at 1910, and then we have another place where they cross, which is right here. It's a 1944, maybe, approximately. About 1944. Somewhere around there. Right, that's what the warm-up should look like. Now we're going to turn this over to the next page, wired or wireless. H of T is the percentage of homes in the United States that have a landline phone in year T. CT is the percentage of homes with only a cell phone. Here are the graphs of H and C. Go ahead and take a minute, pause the video, go through these questions down here on your own, and then once you've done that, then come back and take a look at, I'll go through it with you. Pause. Okay, estimate H of 2006 and C of 2006. So here's 2006 right there. Cell phone only, that's C of 2006. I'll do that one first. That looks like, let's see, if 10 is right half between there, then this is going to be like 13 or something, 13%. And then H, that's up here. If this is 90, then that's about probably 84. So I'm going to say 84%. So if you want to write that down here, you can, or just put it up above, that's fine. Explain what each value tells us about phones. So H of 2006, that's landline phone. So in 2006, so for this one, in 2006, 84% of households had landline. And then for this guy, in 2006, 13% of households had only cell phones. So that's something like that is what you should have there. What is the approximate solution to C of t equals 20? So for this one, we're trying to find the time, the year when we have 20% of cell phones. So we're going to look at the y-axis for 20 and go to right about right there. That looks like where we hit the function that is C, and that looks like, if this is 2007, this looks like 2007 and a half. So let's see, explain what this means. So I would say it would be T is about 2007 and a half, which is like June of 2007. That's what I'm going to say. So in June, because that's halfway through 2007, June of 2007, 20% of households had only cell phones. Okay, number 3, determine if each state equation is true. Be prepared to explain how you know. All right, let's see, if at 2011, so this is saying that cell phone and household is going to be equal in 2011. Let's check that out. 2011 is right here. These are definitely not equal, so that is not true. And let's check 2015. 2015, that's right here, pretty close. They crossed right here, they are equal at that time, so that is true. And that is that page for wired and wireless, but we've got one more question here on the next page. Between 2004 and 2015, did the percentage of homes with landlines decrease at the same rate at which the percentage of cell phones only home increased? Explain or show your reasoning. So for this one, I'm going to show my reasoning. Let's see, decrease at the same rate at which the percentage of cell phones only increase. So what we're going to need to do here is we're going to check the slope of H from 2004 to 2015, and then we're going to check the slope for C of 2004 to 2015. And what I'd like to do is I'll walk you through the H one, and then you can pause it and do the C one. So for H, 2004 is what, like, gosh, let's say if this is 10, let's just say that's 2. 2004, let's say that's 2%. And then for 2015, that one is 50. We'll just say that's 50. That's 50. And so that's going to be the same for this one, because 2015 is when the functions were equal. All right, so now I'm just going to go x1, y1, x2, y2, and I'm going to go 50 minus 2 on the top, and then 215 minus 204 on the bottom. That gives me 48 over 11. And then if I just put that in my calculator, or should I leave it like that and see? Let's leave it like that for right now, and then we'll compare them when we're done. Okay, go ahead and pause, find this Y value, and then for cell phones, oh no, did I just find the cell phones? I did, didn't I? Here, let's just fix this. I found the cell phones. You find the home landlines, because I did the dotted line instead of the solid line. Silly Mr. V. Okay, I found the cell phones. You find the home lines. Go. Okay, hopefully you found the home phone, the landline. So in 2004, that is right about 90. That's what that looks like to me. So 90%. And then I go x1, y1, x2, y2. And I'm gonna go ahead and go 50 minus 90 over 2015 minus 2004. That gives me 50 minus 90 is negative 40 over 11. So if we look at these two, now the question was, does it decrease at the same rate as the cell phone only homes increased? And not exactly, but fairly close. 48 over 11, negative 40 over 11. Let's look at the graph and see if we think that that looks about right. Notice this slope right here and this slope right here, they look like they might be, this one is going down at about the same rate as this one is going up. And that is pretty close to what we got here on our, when we found our slopes. So yeah, I'd say it's pretty close. All right, we are now going on to the next page, which is Activity 2, Audience of TV Shows. This is fun. Number of people who watch TV episode is a function of that show's number. Here are 3 graphs of the functions, represent 3 different TV shows. We're gonna match each description with the graph. All right, so this show has a good, so here's what you do. Pause this, do the work, then come back and check your work. And if you got somebody next to you, check it with each other before you check the video. Here we go. The show has a good core audience. They had a guest star in the 5th episode that brought in some new viewers, but most of them stopped watching after that. So let's see, where's the 5th episode is gonna be, like right here for these guys. And the key with this one is seeing most of them stopped watching after that. And so here is a spike at the 5th episode with the guest, special guest, and then notice how they, those people that spiked for that guest appearance dropped off after that. But the original audience stays pretty steady. So I would say this one is C. This show, for B, this show is one of the most popular shows and its audience keeps increasing. Notice A here, it just keeps getting better and better viewership. So I'm going to say that one's going to be A. For C, this show has a small audience, but the show is improving, so more people are noticing. Oh, that one could be A as well. Let's just put a little light A there. I don't think, well, let's keep moving. This show started out huge, even though it feels like it crashed, it still has more viewers than another show. So if we take a look at this one, here is the huge viewership, looks like it crashed. It still has more viewers than another show, which I think is going to be this one right here that we don't have a graph for. So let's go ahead and put this one is B. Which is the greatest at the 7th episode? Notice A of 7, B of 7, that's a C of 7, that's a 7th episode. So here is the 7th episode. We have right here 1.7 or something million, and then at the 7th episode we've got what, 3.8 maybe, and then for this one at the 7th episode we've got about 3. So oh, look at that, the scale is different. Why would they do that to us? Goodness gracious. Okay, which is the greatest? So they are tricking us a little bit and showing the audience in millions. This Y value is different for all of these. Sneaky. Anyway, the greatest viewership, so according to these ones, is B. What the answer tells us about the shows. The 7th episode, we had this much viewership. I'm not sure what they're asking here, and that's fine. Share your answer with somebody next to you. I'm going to move on to number 3. Use the plane provided to sketch a graph of viewership of the 4th TV show that did not have a matching graph. So it's possible that we need to flip these two. This show is one of the most popular shows and its audience keeps increasing. Now, the reason why this might not be A is because notice I hadn't really paid attention to my Y-axis here. And notice how this one is at less than 1 million viewers as it started. And these ones are all quite a bit higher than that. And so I think this one is going to be A. Small audience because it's less than 1 million and it keeps improving, so more people are noticing. So that makes sense with this one. This one here for B, an audience, it starts at one of the most popular shows, so that means that should start up in the 4 million or more probably, and then it just keeps going up. So this one is going to be our the one that's going to be, we'll just call this one D, because that's the one that's going to be down there that we're going to do for number 3. So for this one, I'm going to label this 2, 4, 6, 8, 10, 12 as a bigger scale like this show B here. And then I'm going to say it starts at one of the most popular ones. So I'm going to just say it starts at like 5 million. And then it just kind of goes up. I'm just going to go 3, 4. And it just keeps getting more. My circles are not awesome. Just something like this. I don't know. It just says it's going up and going up and going up. That's this one here. Keeps increasing. All right. The last section of this lesson here is 3. Let's take a look at this one. We've got 2 graphs. We've got function f is this rounded one and function g is this straight line. Decide which function value is greater for each given input. Be prepared to explain your reasoning. Okay, go ahead and do this. Pause it, come back and check it. All right, we're back. Okay, f of 2 or g of 2. Here's 2. G is greater. See how it's got a greater y value? F of 4 or g of 4. Here's 4. They are the same. Notice that they cross at the same place. F of 6 or g of 6, that's right here. G is this one, F is above it. So F is the greater one, F of 6. And then F of 8 or G of 8, here's 8. F is the one that's above G, so F is greater than G. F of 8 is the greater. Is there a value of x which the equation is, this is true where they're both equal? Yeah, there are actually two. One is x equals 4, and the other one is x equals 9. Both of those guys are where these two are equal. They cross at those 2 points. That would be the explanation down there. Identify at least two values of x at which the inequality f of x is less than g of x is true. So I need two places where the f function is less than the g function. So that's anywhere under here. So I could say 1, where x equals 1, right there, f is less than g. And I can say, let's just do one over here too, 11, x equals 11. So those are two x values for which this inequality is true. The f function is less than the g function. Anywhere underneath that g is going to be true. So this whole line here and this whole line here, or section there. Yep. All right, and we have done lesson 9. Congratulations.